When we're looking at data on a single quantitative variable, one of the first things we want to know is what would a typical or representative value be for the values in this data set? The first answer to that question is the mode. The mode of a set of values is the value that occurs most frequently in the set. If no value occurs more than once, then the set has no mode. And if two values occur with the same greatest frequency, then both values are modes, and the set is bimodal. Here are three examples. This first set, we have 1, 2, 2, 2, 3, 4, 5, 6, 7, and 9. 2 appears 3 times. All the other values appear only once. So the mode is 2 because it appears more often than all the others. In this set, 2, 3, 6, 7, 8, 9, 10, there is no mode because all the values just appear once. No value appears more than once. And then in this third set, we have 1, 2, 4, 6, 7, and 9 each appearing once, but 3 appears twice and 5 appears twice. So both of those values are modes, and that set is bimodal. Now the mode is often used as a way of describing data, but of the ways we're going to look at measuring the center of a data set is probably the least important because, number one, not every data set has a mode, and some sets have more than one. In fact, it's possible for a data set to have multiple modes. Secondly, even if the set has a mode, the mode might not be typical or representative of the entire set. It might just be a fluke that a particular value appeared twice and everything else appeared once, and that doesn't necessarily have anything to do with the actual typical or representative value that we're looking for. And then thirdly, the mode does not generate as many useful applications as the other measures of center do. And that's really what we're interested in, is like, what can we say about the center of a distribution that generates some useful applications and gives us more information down the line. The second measure of center that we're going to look at is the mean, which we abbreviate with this little symbol x with a bar over it, and we say x bar when we're talking about that. Okay, the mean of a set of values is the sum of the values divided by the number of values, which we're going to always abbreviate with the letter n. You've done this many times. You've averaged lots of things, and that's what the mean is. It's just a simple average. You add up all the values, you divide by how many values you have, and there you go. In this set, it has 10 values, so n is 10. We just add up those 10 values together. We get 41 for that total. We divide by the number of values, 10. We get 4.1 for that mean. In the second example, 2, 3, 6, 7, 8, 9, 10, there's 7 values, so n is 7. We add them all up. We divide by 7. We get 45 over 7, or about 6.4 for a typical value in that distribution. Now, one thing you got to be aware of is that these two values right here, x bar 4.1 or x bar 6.4, those are not actual values in the data set. With the mode is a value that's in the data set, but the mean does not have to be in the data set. It just kind of gives you a rough idea about where a typical value would be, not an exact value that's in the data itself. So this one is exactly 4.1. This one is rounded to 6.4, and these are not values in the data set. So the mean does not have to be an actual data value. Now, the three major measures of center we're going to look at, the mean is the most important. It generates more useful applications than the other measures of center do. Now, it might be difficult to calculate in some situations. That's just the way life is sometimes. But the more serious disadvantage of the mean is that it's easily influenced by extreme values. That is, it's not resistant to extreme values. And this concept of resistance is very important when we're talking about measures of center or later on measures of spread. Now, if you take this data set that we looked at before, it had a mean of about 6.4. If you change that 10 to a 100, that's going to affect the mean. You're now adding 100 here instead of 10. The total is now 135 for all the data values. Divide by 7, you get 19.3. So changing that one value from a 10 to 100 had a big effect on the mean. Okay, that means the mean is not resistant to this big value. The third measure of center we're going to look at is the median. The median of a set of values is the middle value when the values are listed in increasing order. If the number of values is even, then the median is the mean of the two middle values in the ordered list. For instance, in this list, which is already ordered, you can see there are 7 values. The 4th value is the middle one, so the median is 7. On this list, there are 10 values, so there is no middle value, but we're going to average these two middle ones, the 5th and the 6th, which are 3 and 4. Add them up, divide by 2, you get 3.5 for the median of that set of data. Okay? Now, the median is not as commonly used as the mean, but it is often easier to calculate. And more importantly, it's resistant to extreme values. This is a very important and valuable characteristic of the median, is that it is resistant. If we were to change this value of 10 to 100 here, well, the middle value of this list is still 7, and so the median is still 7. So whatever these values are at the extremes, it does not affect the median. And they could be very large numbers or very small numbers, and the median would still be 7, as long as you have 7 values in your list and the middle one is remaining 7, that median is always going to be 7. Now, the median is halfway through the ordered list, and so it divides the data in half. The lower half has a median. It's called the first quartile, which we abbreviate with Q1. The upper half has a median. We call that the third quartile, or Q3. And these quartiles are also resistant, just like the median is. When you're calculating the quartiles, you do not want to include the median in either half of the data. Here's how that would look. Okay, if you have this list right here, we're not going to include the median in the lower half, so we're just going to find the median of this 2, 3, and 6, which is 3, and that means the first quartile is 3. The median of the upper half, 8, 9, and 10, is 9, so that's Q3. In this list right here, the median is actually between 3 and 4. It's not a value in the data set. So you can take all 5 of those values right there, and the middle one would be 2. That would be your first quartile. And all 5 of these values here, the middle one would be 6. And so the third quartile would be 6. Now you can generate what they call a 5-number summary from an ordered list like this. It just consists of the set's minimum value, its first quartile, its median, its third quartile, and its maximum value. And it gives a nice, neat, compact way of summarizing the information that's in a quantitative data set. For example, in this set, which we've looked at before, the minimum value is 1, the first quartile is 2, the median is 3.5, the third quartile is 6, and the maximum is 9. And there it is, a 5-number summary. So that's a very useful way of summarizing a data set. Now you can find the 5-number summary on your calculator. On a TI-83, we have lots of statistical functions, and the place where you access most of them is right here at the Stat button. So if you want to find the 5-number summary of a data set or the mean of a data set, you can often just go in here, you press Stat, select Edit just by pressing Enter, and then you open up these lists. This is the data editor. You've probably seen this before in some of your algebra classes. You're going to type your data in list 1. So if we use the data set that's on your screen, 1, 2, 2, 2, 3, 4, 5, 6, 7, and 9. We now have the 10 values in the data editor, and what we can do is quit, go second mode and get out of there, and then go Stat, go over to Calc, and then select one variable stats from the list just by pressing Enter. And then you can tell it what list the data are in. If your data are in list 1, that's the default. You don't have to say anything right here. But if there's somewhere else, you would want to tell the calculator where those are. So I'm just going to put that in so that you can see that that's how you tell the calculator where the location is for your data. And you press Enter, and then the calculator calculates the mean. Here's X bar, 4.1, as we saw before. And then the 5-number summary is down below. You see this arrow and this cursor. Okay, the arrow means there's more. Scroll down, and you'll see your 5-number summary appear. Your minimum is 1, your Q1 is 2, median is 3.5, Q3 is 6, and the maximum is 9. So there's your 5-number summary. Easy, you can get it on your calculator in a snap.